Good morning friends. Up to this we discuss about MCQ question of chapter 10 where optics are asked in good set. Now up to the 2011 we discussed in earlier portion. Now today we are starting from what are the questions asked in 2012. Now first is what is the angle between plane of polarization and direction of propagation of beam of plane polarized light. Now, only from the figure of the polarization we can judge about that what is the angle between plane of polarization and direction of propagation. Direction of propagation of a plane polarized wave is in the same direction of the plane of polarization. That means the both are in the same direction, therefore the angle between them is zero. Angle between them is zero. Again, read the question carefully. What is the angle between plane of polarization? That means the plane in which the polarized light is obtained and the direction of propagation of beam of plane polarized light. Okay, so both are in the same direction, therefore the angle is theta is equal to 0. Now next is in Young's double slit experiment that is also asked in 2012, the intensity at a point P on the scale is half of the maximum in the interference pattern. If the wavelength of the light is lambda, d is the distance between the slits, and we have to find out the angular separation between the point P and center of the scale. Now in Young's double slit experiment, the situation is this. These are the two slits. The separation is given the small d. Here the point P. At point P, the intensity is I0 by 2 or the I by 2. We have to find out this angle of separation. For that purpose, we are using the equation of intensity at point P in interference pattern. Now, what is the equation? I is equal to I0 cos square into bracket k into R1 minus R2 upon 2. Now we are using this equation. I is equal to I0 cos square k R1 minus R2 upon 2. Right? That is the equation of the intensity of a light at any point in interference pattern. We can calculate. That is depends on the path difference at this point. K is the wave vector, its value is 2 pi upon lambda. Here the intensity at point P is given the I0 by 2. That means the half of the maximum interference pattern. Therefore, there is the I0 by 2 is equal to I0 cos square K R1 minus R2 by 2. I0 cancel. That means the 1 by 2. 1 by 2 is equal to cos square. Now listen. K is equal to 2 pi upon lambda. Here we substitute 2 pi upon lambda. Now, at point P, the path difference is d sin theta upon 2. That is the d sin theta upon 2. Therefore, 2 to cancel. Right? Therefore, 1 by 2 is equal to cos square pi d sin theta upon lambda. Pi d sin theta upon lambda. Now take the square root on both sides. Therefore, 1 upon 2 cos pi d sin theta upon lambda. Pi d sin theta upon lambda. Now we know that 1 upon 2 is the cos 45 and the cos pi by 4. Therefore, pi by 4 is equal to pi by d sin theta upon lambda. Pi is cancelled. Therefore, sin theta is equal to lambda upon 4. Sin theta is equal to lambda upon 4d. We require the angular separation, that means the value of theta. Therefore, theta is equal to sin inverse lambda upon 4d. Lambda upon 4d. So there is the angle between the point P and center of the sphere. Clear this? So this we obtain the theta is equal to sin inverse lambda upon 4d. Again, here the intensity at point P is the half of the maximum intensity. Wavelength is lambda, separation between the two slits is d, and we have to find out the angular separation of point P from the center of the sphere. That is the center of the sphere. So this theta we require. For that purpose, we are using the concept of intensity of light at any point on the sky in interference pattern. I is equal to I0 cos square k I1 minus I2 by 2. Okay. Now, intensity is given I0 by 2. I0 by 2 is equal to I0 cos square k I1 minus I2 by 2. I0 cancel, we obtain the 1 by 2 cos square. Now, k, wave vector, its value is 2 pi upon lambda. Now, I1 minus I2 is the path difference at point P. So, we know that the path difference is equal to d sin theta upon 2. So, substitute here d sin theta upon 2. Therefore, 2 cancel, only pi d sin theta upon lambda is remaining, is equal to 1 by 2. Here the cos square, x square root 1 upon 2 is equal to cos pi d sin theta upon lambda. Now, 1 upon 2 is the value of 45, cosine of 45, or the cosine of pi by 4. Therefore, pi by 4 is equal to pi d sin theta upon lambda. Pi cancel, we require the sin theta. Therefore, sin theta is equal to lambda upon 4d. Therefore, theta is equal to sin inverse lambda upon 4d. After that, the next question asked in 2013, that is the quite interesting. In Young's experiment, the central fringe of interference pattern produced by light of wavelength 6000 angstrom. The central fringe is superposing to fourth order diode fringes after a glass plate of effective index 1.5 ECD. So what it says then? First, by using the wavelength of light 6000 angstrom, we obtain the central diode fringe at a given point. Now, yes, we place the glass plate in the path of this incident light, and the effective index is 1.5. At that time, instead of the central diode fringe, here we obtain the fourth diode fringe. Right? So in that case, what is the thickness of a glass plate? Therefore, keep in mind this equation. Thickness of a glass plate T is equal to XD upon capital D mu minus 1. Right? X is the point. X is the distance of the point for which we obtain the diode fringes and also the fourth diode fringes. Now we know that the xd upon d is equal to 2n minus 1 into lambda by 2. But we know that xd upon d is equal to 2n minus 1 into lambda by 2. Because diode fringes is superposed. Therefore, here we use the condition 4. The diode fringes, that means the destructive interference 2n minus 1 into lambda by 2. Substitute here for, in this case, take n is equal to 4. Therefore, x small d upon capital D is equal to 4 into 2, 8 minus 1, 7 lambda by 2. 7 lambda by 2. Substitute in equation 1. Substitute in equation 1. Equation 1 is T is equal to, instead of this part, we substitute the 7 lambda by 2. Therefore, 7 lambda upon 2 by into mu minus 1. 7 lambda into 2 into mu minus 1. Okay. Now, wavelength given, mu given, therefore T is equal to 7. Wavelength is 6 into 10 is 2 minus 7 meter, 6000 angstrom, and here 2 into 1.5 minus 1. Therefore, we obtain 4.2 into 10 is 2 minus 6 meter is the thickness of a glass plate placed in the path of the incident light, so that the point at which the central fringe is obtained, at the same point we obtain the fourth dark fringes. Again, this question, in Young's experiment, the central fringe of interference pattern produced by light of wavelength 6000 angstrom, so that the central fringe is supposed to fourth dark fringe. After a glass plate of the effect index 1.5 is introduced, the thickness of the glass plate. So for that purpose, keep in mind this equation E is equal to x small d upon capital D into mu minus 1. This equation is given in all our syllabus of Gujarat board. Now in NCERT directly that is accepted. But now listen, xd upon capital D from the condition for the path reference for the dark fringes, so the destructive interference, xd upon d is equal to 2n minus 1 into lambda by 2. Take the n is equal to 4 because the fourth dark fringe is superposed. Therefore, xd upon capital D is equal to 7 lambda by 2. Substitute this value in equation 1 as xd upon capital D. Therefore, T is equal to 7 lambda upon 2 into mu minus 1. Lambda is given, mu is given, substitute and find out the thickness of a glass plate, 4.2 into 10 is 2 minus 6 centimeter. 6 meters, sorry. Now next, also asked in 2013, two beams of the light of intensity I1 and I2 interfere to give the interference pattern. If the ratio of maximum intensity to the minimum intensity is 16 by 4, then what should be the intensity of these two waves? Now listen, there is a quite US question. Already this type of the numerical we calculate. At that time the ratio of the I1 upon I2 is given. We have to find out the ratio of I maximum to the I minimum. But here the ratio of the I maximum to the I minimum is given. From this we have to find out the ratio of I1 upon I2. For that purpose we know that I maximum upon I minimum is equal to A1 plus A2 whole square upon A1 minus A2 whole square. This ratio is given 16 by 4. Take the square root on both sides. So it's equal to 4 for the 16. Therefore 4. Take the square root. A1 plus A2 upon A1 minus A2 is equal to 2. Therefore, A1 plus A2 is equal to A1 minus 2A2. Therefore, A1 is equal to 3A2. A1 is equal to 3A2. Therefore, I1 upon I2 is equal to A1 square upon A2 square. Therefore, 9 by 1. Therefore, ratio of I1 upon I2 is equal to 9 by 1. Therefore, I1 raised to I2 is equal to 9 raised to 1. 9 raised to 1. So, thus we find out the ratio of the intensity of the wave if the ratio of the maximum to the minimum intensity of the waves are given. Using this concept, I maximum upon I minimum, A1 plus A2 whole square upon A1 minus A2 whole square. Because we know that the I proportional to the, that means the intensity is directly proportional to the square of amplitude. Here the two waves are superposed. So in that case, the maximum intensity is obtained when the both crest or the tone of both waves are superposed. That means the amplitude increases, and when the amplitude is decreases, then the minimum intensity obtained. So there is given 16 by 4, there is the 4. Therefore take the square, a1 plus a2 upon a1 minus a2 is equal to 2. Right? a1 plus a2 upon a1 minus a2 in here we take the addition and denominator we take the subtraction. Therefore we obtain the a1 is equal to 3. Therefore I1 upon I2 is equal to a1 square upon a2 square is equal to 9 by 1. So this ratio is 9:1. Now friends, new numerical. In Young's double slit experiment, if the width of the fourth band fringe is 2 into 10 is to minus 2 centimeter, and what is the width of the sixth band fringe? Now listen, this question is quite logical. In Young's double slit experiment, what are the fringes obtained on the scale? The width of the fourth band fringe is given 2 into 10 is to minus 6 centimeter. Now, what should be the width of sixth band fringe? Now listen, in Young's experiment, what are the fringes obtained? These are the interference fringes. In interference phenomena, all the fringes of equal width and equal intensity. Therefore, what is the width of the fourth band fringe? The same width of sixth band fringe. Clear? Because already we discussed about that interference fringes, all the fringes of equal width and equal intensities. We do the graph of intensity versus distance. All interference fringes of equal width and intensities. That means the intensity and width of all the band fringes are same in interference fringes. Clear this? Okay. After that, the diameter of the pupil of the human eye is 2.5 millimeter. Capital D is given. Wavelength of the light used is 5000 angstrom. What must be the minimum distance between the two-point object to be seen clearly? That means the image of this two-point object we can see clearly. If they are a distance of 5 meters from the eye, distance of the object from the eye is given. That means there is the pupil diameter of the eye is D. Distance is given the two-point object. That is the f is equal to 5 meters. Wavelength of the light is used. Therefore, we are using the equation x is equal to 1.22 lambda upon d. Right? Okay. Therefore, what we have to find out, what must be the minimum distance? The minimum distance is x is equal to 1.22 lambda f upon d is equal to 1.22 lambda. Wavelength of the light used 5 into 10 is to minus 7, and f is equal to 5 meter distance. That is the distance of the object from the eye. That is the 5 upon capital D, diameter of the eye, that is given 2.5 millimeter, converted to meter. Therefore, 25 into 10 is 2 minus 4 meter. 5 into 25, that is cancelled. Therefore, 1.22 into 10 raised to minus 3 meter. There is the separation of the image of these two objects. Right? There is using the equation of the telescope. What is the minimum distance between the object? 2-point object. If the two objects are this distance and 5 meter distance from the eye, we can see the clearly by our naked eye. The diameter of the pupil of the human eye is 2.5 millimeter. Wavelength of light used is 5000 angstrom. What must be the minimum distance between 2-point objects to be seen clearly? Right? If they are at distance 5 meter from the eye. Okay. For that purpose, the equation of the minimum distance x is equal to 1.22 lambda f upon capital D. Here, lambda is the wavelength of the light used. F is the distance of the object from the eye, and capital D is the diameter of pupil of human eye. Substitute the value. So, thus we find out if the two objects are separated by this distance and also 5 meter distance from the eye, we can see its image clearly. After that, the next question, Article 2014. Unpolarized light falls first on polarizer P and then on analyzer A. If intensity of transmitted light from the analyzer is 1/8 of the incident unpolarized light, so what will be the angle between optics axis of P and A? For that purpose, from the Malus law, intensity I is equal to I0 by 2 cos square theta. Right? Because here the unpolarized light first passing to the polarizer and then incident on the analyzer. Now, where the light is coming out of the analyzer is 1/8 part of intensity of the unpolarized light. Right? Cos square theta. Therefore, 1/4 cos square theta. 1/4 is equal to cos square theta. Take the square root, 1/2 cos theta. Therefore, theta is equal to 60 degrees. Again, the Malus law, the intensity of the light coming out when the image out from the analyzer, I is equal to I0 by 2. Here, I is equal to I0 by 2 cos square theta. Theta is the angle between the axis of polarizer and analyzer. Here, the light first passes through the polarizer and then analyzer. Therefore, we take the I0 by 2. That is the half intensity of the light is immersed out from the polarizer. And I0 is the light of intensity of unpolarized light. Therefore, I0 by 8 is equal to I0 by 2 cos square theta. So here I0 is cancelled, 1/4 is equal to cos square theta. Therefore, 1/2 is equal to cos theta, and therefore theta is equal to 60 degrees. After that, a plane polarized light is incident normally on a dominant plane. Its E vector makes an angle 60 with the optics axis. Right? Optics axis is the plane. Find the percentage difference between initial and final intensities. So from Malus law, I is equal to I0 cos square theta. I is equal to I0 cos square theta. Right? Theta is equal to 60. Therefore, I0 cos square 60. Cos 60 1/2 square of this. Therefore, I0 by 4. I is equal to I0 by 4. Now we require the percentage difference between the initial and final intensity. Therefore, initial minus final upon initial multiply by 100, there is a percentage difference. There is a percentage difference. So is equal to I0 minus I is equal to I0 by 4 upon I0. Therefore, 4I0 minus I0 upon 4I0 multiply by 100. Also multiply by 100. Therefore, 3I0 upon 4I0 multiply 100%. I0 is your cancel 3 by 4, 75%. First, find out the final intensity. Now here, a plane polarized light is incident normally on a dominant plane. Its E vector makes an angle 60 degree with the axis of the plane. Then, find the percentage difference between the initial and final. Initial intensity is I0 and what is the final? So here I is equal to I0 cos square theta. Theta is the angle between the E vector of plane polarized light with the axis of a polarization. So I0 cos square theta. Here theta is equal to 60, therefore I0 cos square 60, therefore I0 1 by 2 whole square, therefore I0 by 2. Now the percentage difference between initial and final, I0 minus I upon I0 multiplied by 100% is equal to I0. Final intensity is I0 by 4 upon I0 multiplied by 100. Take the LCM, therefore 4I0 minus I0 upon 4I0 percentage 100. So it's equal to 3I0 upon 4I0 multiplied by 100%, therefore 75%. 75%. Now connect next 2015. What is given? Light of the wavelength lambda is incident on a slit of width d. The resulting diffraction pattern is obtained on the screen plane at distance d. Now there is the screen. Here the width of the slit is d. So this angle is theta. So this angle is also theta. This distance x, there is that. This point is our O. This point is our O. There is P and there is the P. This distance is given D and there is the width of the slit is also small. Okay, now pattern is obtained, observe on the screen, flash at distance D. The linear width of the central maximum is equal to width of the slit. Now, linear width of the central maximum, this distance, is given as the small d. Then, what is the distance d of the screen to the slit? For that purpose, first order diffraction. First order diffraction. We know that d sin theta is equal to lambda. For small angle, for small theta, d theta is equal to lambda. Right? Now, total linear width, that means on both sides of O, both sides of O, therefore d into 2 theta is equal to 2 lambda. From equation 1, theta is equal to lambda upon d, that is the equation 1. Therefore d, here 2 lambda upon d is equal to 2 lambda. 2 lambda upon capital D. Theta, d sin theta is equal to L. There is a equation 1 and here we are using 1. Theta is equal to x by capital D to the figure. Therefore, 2 lambda upon capital D. But linear width is given 2x. 2x is equal to small d. Therefore, d upon capital D into small d is equal to 2 lambda. Therefore, d square upon d is equal to 2 lambda. Therefore, d is equal to d square upon 2. Now we search for the figure. We are using the condition for the minima of the first order diffraction. D sin theta is equal to actually n lambda, n is equal to 1. Therefore, d sin theta is equal to lambda. And now theta is very small. Therefore, d theta is equal to lambda. And also we know that the sin theta is equal to x upon capital D. Theta we consider the very small. Therefore, theta is equal to x upon capital D. Now, on the both sides of this central maximum, so d into 2 theta is equal to 2 lambda. Substitute the value of d here. Small d 2 theta is equal to x upon capital D is equal to 2 lambda. Here the linear width is same as the width of the sling. Therefore, 2x is equal to small d. We take as, so d into small d upon capital D is equal to 2 lambda. Right? Therefore, d square upon capital D is equal to 2 lambda. Therefore, capital D is equal to d square upon 2